All right, so for question number 2, we're using the same data as question number 1. They're just asking for the point of estimate. So let's see, since it's the same data, I don't have to worry about that. So the point of estimate, we just have to punch into the formula. So we're basically using the first sample mean minus, in column number 1, minus the second sample mean, which would be column number 2. And we just punch in those numbers, so we get the sample mean of 214.71 from column 1, from the pH column, minus 193.20, which we find in the second column. That leaves us with 21.54. And now we just have to use the standard of error formula, and that would be our standard deviation squared over our total number, like this total sample size, which we can find here, which is the 133, over the standard deviation squared, like 2 squared. So that's where we get our 33.04 because it's in column 2, and then we get the 29.66 because that's in column 1. But we're going to square that, and we're going to square this guy, and we're going to put those over our total numbers in the column. So 29 corresponds with the same column, 133, so I put that over that, and then we are going to put it over the 41 from that same column from 33.04, and it roughly comes out to about 5.765. So let's see, the next part of the question is, can you apply the central limit theorem to estimate the population mean in the primary hypertension patient's total cholesterol? Okay, so yes, you can. And the way that I figured that out is that basically the central limit theorem is used for significantly large samples. So we do know that if it's larger than 30, we can use the central limit theorem. So if it's larger than 30, you're using your sample size here. So we can determine that 41 is larger than 30 and 133 is larger than 30. So we definitely can use the central limit theorem. Now, so here comes some math involved. So we got to use the confidence level. Let's see. So find a 90% confidence interval of population mean the primary hypertension patient's total cholesterol, and also interpret the meaning. So we here are just going to plug in our sample mean. So we're basically just going to use this formula here, which is our sample mean 1, our sample mean 2, plus or minus our test statistic times the standard of error. So here, I basically punched in, we do know from the previous that our critical value is 1.645, and we're basically we're going to punch that into our formula here. And basically, we determine that 21.51 plus or minus 9.483. So when we do add we do add these together, we get our 30.993. And then when we subtract 21.54 from the 9.483, we get 12.027. So with that, we can determine that we are 90% confident that the difference in the population means lies within this interval.